Hello students, I am Vijay Kumar Patel, PGT Chemistry, JNV Golaghat, Assam. Today I am here for class 12. Today we will discuss here about in the syllabus unit number 3, Electrochemistry. In Electrochemistry, today we will learn about the Daniell cell and electrochemical cell. So my dear students, first let me tell you what are electrochemical cells. So those devices in which chemical reaction produces the electricity, means due to chemical reaction if electricity is produced, then those devices are known as electrochemical cell. For example, the cell which we are using in our wristwatch or in wall watch or in radios, the dry cells or batteries, secondary cells. So these are the devices, these are the instruments by which we are producing electricity, and this electricity is produced due to the chemical reaction. So earlier the first electrochemical cell, it was invented by Daniell. So on the honor of Daniell, the cell was named as Daniell cell. So let's see first the structure of Daniell cell. In this Daniell cell, scientist Daniell, he took two beakers. In first beaker, zinc electrode, it was dipped in zinc sulfate solution. I have here colored this by yellow so that you can easily distinguish the different structures here, but actually the color of zinc sulfate is white. So here zinc metal, it is immersed or it is dipped in zinc sulfate solution. Like that, copper metal, it is dipped in copper sulfate solution. These two beakers are connected via inverted U-shaped tube which is known as salt bridge. Then these two electrodes are connected via wire and one galvanometer is there. This galvanometer is used to find out the flow direction of the flow of electrons. So here see students, the structure is completed. Once again, zinc electrode, it is dipped in zinc sulfate solution. Copper electrode, it is dipped in copper sulfate solution. Both the solutions are connected via salt bridge, in which a solution of KCl or solution of agar-agar, it is filled and electrolyte is filled. These two electrodes are connected via cable or wire. Then now see this zinc, it is called anode, and second copper, it is called cathode. It means not only copper, this half cell, since it is complete cell, okay. So in complete cell we have taken two beakers, so one beaker is known as half cell. So simply we can say half cell we can prepare by immersing metal into its solution. So this is half cell, this one is half cell, and this one is complete cell. So in this cell, now see the chemical reactions. First, let's talk about zinc and zinc sulfate. So in my previous video, I have told you about the electrode potential, means tendency of a element to undergo either oxidation or reduction. So here, see in chemical reaction, at cathode, Cu2 plus ion, copper ion, it gains 2 electrons and forms copper atom. This copper atom deposits on this copper electrode. It means in this cell, this is cathode. Why this is cathode? Later we will discuss. So in this cell, copper ion from solution, because here in solution I have taken copper sulfate. So here in copper sulfate, Cu2 plus and SO4 2 minus, these two ions are present, okay. Then this copper, it gains 2 electrons and forms Cu atom, which is in solid state. So this solid means copper ion from solution, it deposits on this copper electrodes, means direction will be this. From here Cu2 plus, it will deposit around this copper electrode, okay. So this is reaction in cathode, and always since it is gaining 2 electrons, so the gaining of electron, it is known as reduction. So at cathode, reduction reaction will take place. So that's why remember this thing, at cathode always and always reduction will take place, and at anode always and always oxidation reaction will take place. So since in this copper electrode reduction is taking place, that's why it is named as cathode. Let's talk about anode, means second half cell in which zinc is immersed in zinc sulfate solution. So here the reaction is this zinc atom, it removes 2 electrons and forms Zn2 plus ion. Means in this cell the Zn which is in this electrode, so this Zn forms Zn2 plus and 2 electrons. So here 2 electrons, they move in this direction, and Zn2 plus it goes into solution. So students, in this cell, now see what is happening. At anode, zinc from metal, it is going into solution, and at cathode, copper ion from solution, it is depositing on metal, copper metal. So here direction is reversed, from metal to solution, from solution to metal. These two different reactions are there. And since this is an example of oxidation, that's why I told you that zinc electrode, it works as anode, and copper electrode, it works as cathode. Now see the overall reaction. So if you combine these two reactions, you will find that on cancelling these 2 electrons, you will get the relation or the equation Zn plus Cu2 plus, they form Zn2 plus and Cu. So here we can easily understand that at cathode reduction will take place, and at anode oxidation reaction will take place. Then come to the next. Next is representation of cell. How can we represent a cell? So here, to represent the cell, we will use here, it is represented in this form: anode, then parallel vertical lines, 2 vertical lines, and then cathode. So students, here these 2 vertical lines, they indicate that these 2 cells or these 2 half cells, these are connected via salt bridge. So these vertical lines, this means salt bridge. And what is the application of salt bridge? Why we are using here? Later we will discuss. Here see representation of cell. Anode on the left side, 2 vertical lines which indicates the presence of salt bridge. Then cathode. At anode, which reaction is taking place? So at anode, zinc is converting into zinc ion. So at anode, zinc metal, it is converting into Zn2 plus, which is going into solution. Then at cathode, which reaction is taking place? It's a reduction. So Cu2 plus ion from solution, they convert into Cu atom or Cu solid. So this is the representation of cell. Here see, if in your question the reaction is given, then we can easily find out which is anode and which is cathode. On the left side always anode is written, on the right side always cathode is written. Then after representation of cell, now we come to the point, that is calculation of electromotive force EMF or E naught cell. Electromotive force, it means simple, in simple word we can say how much electricity is produced by this cell. That is electromotive force. You have heard about that pencil cells. They produce energy of 1.5 volt. So 1.5 volt means what? Their EMF is 1.5. So how much energy is produced by the cell is called electromotive force. Definition I have told you in my earlier video. Then see, E naught cell, this naught indicates in my previous video I told you that E naught cell, it indicates the standard condition. Standard condition means the concentration of the solution, it should be 1 molar. Then the length of the electrode and the area of the cross section, all about that I have discussed in my previous video. So here see, this naught indicates the standard condition. So E naught cell, it is equal to always and always electromotive force. This is the difference of the electrode potential of anode and cathode. So E0 cell, it is equal to E naught cathode minus E naught anode. Now the cathode, so at cathode copper is present, so we represent E naught Cu2 plus oblique Cu. This is the reduction potential, standard reduction potential. So E0 Cu2 plus oblique Cu minus E naught Zn2 plus oblique Zn. So this is anode, this is cathode. The difference of their electrode potential is known as electromotive force. So from electrochemical series, you can easily find out the value of standard reduction potential for copper and standard reduction potential for zinc. For copper it is 0.34 and for zinc it is minus 0.76. So if you solve it, you will find the answer 1.10 volt. It means the electricity produced by this Daniell cell, the electricity is 1.10 volt. So all these cells are made under standard condition. So this is the electromotive force or E0 of cell. Then as I told you, these two beakers are connected by a salt bridge. So here now we will see the importance of salt bridge. Here we are going to discuss about salt bridge. This salt bridge is inverted U-shaped, in which the solution of electrolyte like KCl or agar-agar solution, it is filled and the both ends are packed by cotton plug. Okay, if you don't use cotton plug, the electrolytes, they will directly go into different solutions. So we have packed this the mouth of this tube by cotton plug. Then next, what is the importance? First importance of salt bridge, it is it completes the circuit. How? So see here how it is completing. When electrons, these electrons or the charge or the electricity, it is producing from here because electrons are moving in this direction. At anode, electrons are produced, means the direction of electron is this one. So electrons, they are going from here. See how? From here I am starting. Electron goes up, then okay. So the direction of electron is this. So this circuit is not closed circuit now. So that's why the electricity will not flow. Here to complete this circuit we are using salt bridge. So how the electricity the circuit is completed? So see here, electrons are moving from here or the charge is moving from here. From here it is going, come to the solution. From solution through this electrolyte, it is now coming into this. So the direction is now this. So this is a complete circuit. It means the first importance of salt bridge is it completes the circuit. Then second importance, you see, due to the chemical reaction, which chemical reactions? At anode, from electrode, Zn2 plus ions, they are going into solution. So with that time, the concentration of Zn2 plus in solution, it will increase, because earlier here the total Zn2 plus, they were equal to total sulfate. Zn2 plus, these are equal to Zn equal to SO4 2 minus. So when there was no chemical reaction it took place, then the concentration of Zn2 plus, it is equal to SO4 2 minus, means this cell was electrically neutral. With the reaction, Zn2 plus, they are releasing into the solution. So with that time, the concentration of Zn2 plus, it will increase, and these Zn2 plus will deposit around this electrode. So now after some time, it will be impossible to release some more Zn2 plus into solution. Why? Because they will form here a blockage. So that's why now the electricity, the production of electricity, it is not possible. In the same way, at cathode, since in solution Cu2 plus, copper sulfate means Cu2 plus and SO4 2 minus, these two ions are present. So these Cu2 plus, they gain 2 electrons and form Cu metal, and these metal deposits on this electrode. So with that time, the concentration of Cu2 plus it will decrease, and SO4 2 minus it remains same. So with the time, this cell it has maximum negative ions. So this cell has maximum positive ions, these are Zn2 plus, and this cell has SO4 2 minus. So my dear students, here see, with the time, since the solution now it is no longer electrically neutral, so the production of electricity it will be stopped. So now the importance of this salt bridge is to revive the cell. How? So see here, in cell I have taken KCl, potassium chloride. So how this potassium chloride neutralizes these two half cells? See, at anode the concentration of Zn2 plus it was increased. So I am writing like this. Suppose there was only 1 mole ZnSO4 solution, means 1 Zn2 plus, 1 mole Zn2 plus and 1 mole SO4 2 minus, they were present. With the time, the concentration of Zn2 plus it was increased. So that's why the solution was overall positively charged. So from KCl solution, the chloride ions, two chloride ions, they will move toward this cell, this half cell, and it will form ZnCl2. This is electrically neutral. Again 2Cl minus, again it is ZnCl2 electrically neutral. So with the movement of chloride ions, this half cell it is now becoming electrically neutral. In the same way, come to the cathode. So at cathode, the concentration of sulfate ions it was increased, means if 1 mole of copper sulfate was taken, see here, 1 mole of copper sulfate was taken. So with the time Cu2 plus they are removed from solution. So the concentration of SO4 2 minus it remained constant. Okay. So now this solution is overall electrically neutral. Remember this thing, concentration of SO4 2 minus it is not increasing, it is same. The concentration of Cu2 plus it was decreased. So now what happens, with the time 2K plus ion they will combine with this SO4 and they will form K2SO4, electrically neutral. Again 2K plus SO4 2 minus, again it is K2SO4. So with the movement of K plus ion towards this cathode, the solution it will now becoming electrically neutral. So here these two half cells which were positively charged and negatively charged respectively, now they became electrically neutral. So again the cell will start working and electricity will be produced. So the importance of salt bridge, there are two importance. Number one, it completes the circuit, and number two, it revives the cell by making these half cell electrically neutral. Okay. So students, this was the here one more thing. How do we know that electrons are moving or the electrons are releasing from zinc? Because we can't see electrons. So here this instrument was used which was known as galvanometer. So this galvanometer indicates the flow of direction of the flow of electrons. How? So when there is no flow of electricity, okay, when there is no flow of electricity, then the direction of the needle it is like this. If electrons are moving in this direction, this needle will be like this, and if electrons are moving in this direction, means in this direction, then needle it will deflect in this direction. So right side or left side, the needle it is deflecting, it indicates the direction of flow of electrons. And as you know, the direction of flow of current it is opposite to the direction of flow of electrons. So electrons are moving from zinc to copper. At the same time, current or the electricity it is flowing from copper to zinc. So students, this is the Daniell cell or electrochemical cell, first electrochemical cell. Now we can construct some more electrochemical cells by using the same concept. Okay, this is for your innovation or for your idea. If what we have to do, we have to take two different metals, okay, dip those metals into their solutions, connect via salt bridge and via galvanometer or complete the circuit. Then you can see the voltage. Okay, so in this way we can prepare different types of electrochemical cell, not only Daniell cell. It was the prototype of the electrochemical cell. So that's all for today's discussion. If you have any doubt, you can ask me in my personal WhatsApp number. If you like my video, please like and subscribe. Thank you very much. Have a nice day.